Hi, this is Miss Logan. Today I'll be talking about the basics of periodic and circular motion. Periodic motion is a very general term for any time a motion repeats itself over and over again. The most classic example of this that we'll explore really in depth in this unit is a pendulum. So a pendulum swings back and forth forever and ever. We also have anytime we have circular motion. This is actually periodic motion. Why? Because it's moving in the same exact rate all the way around. An example we'll see of this in real life is a grandfather clock. So this pendulum right here is moving back and forth so that it keeps the time. Periodic motion is defined in two different ways. Two words that you've probably used but may have not used them correctly, kind of like speed and velocity. So first we have the frequency, okay? The frequency is the 1 over periodic time, okay? So something important to note is that period is equal to t, okay? Why? Well, first of all, we ran out of letters, and period is always in seconds, which is time. So if we go back to frequency, frequency is 1 over period, or 1 over big T. The unit we use for this is hertz, which is also 1 over seconds. Now the period is also very important, and this has an inverse relationship with frequency. So the period is 1 over frequency, or 1 over f seconds. So it's important to remember that when we're talking about period or periodic time, it's actually just a time unit. Now, if a pendulum going back and forth, if it starts at the very top and then it swings, reaches its other highest point, to make one full period, it has to come all the way back here. So once again, I have to move all the way over to our other high point and then all the way back to have one full period. So we might be able to test this and tell that our period is equal to 3 seconds. And we can actually just take that data using a photo gate or other technology. Now, if I want to figure out my frequency is 1 over the period, big T, so 1 over 3 hertz. So let's look at an example problem. A dog wags its tail 30 times in 20 seconds. What is the period and frequency of the tail wag? Well, we know over 20 seconds, the dog wags its tail 30 times. Now, if we're looking for period, we have to have seconds on top. So we can figure out that our period is 2/3 seconds. So every 2/3 of a second, the dog wags its tail once. Now, if we want to figure out frequency, we're going to do the opposite because we want seconds on the bottom. So I have 30 times over 20 seconds. For frequency, we always want seconds on the bottom. So for our frequency, I'm going to get 3 over 2 hertz. So it's really important in this particular unit that we're paying attention to our units. Now, the other part of this unit that we'll discuss a little bit is circular motion. Now, we will not be doing any equations for this. We'll only be looking at conceptual or big picture parts. Okay, so circular motion is any time something is moving around an object at a constant speed. That's the most important part. It is not accelerating, it is moving at a constant speed. Now this r here is the radius from the center of the object that it's moving around to the actual object. So this thing is moving around forever and ever. Now you notice in that previous example I said constant speed. So once again, we have a constant speed. But what about velocity? Well, if we think all the way back to our first unit, velocity has a lot to do with direction. So as this object is moving around, while its speed is staying constant, its velocity is changing. Why is it changing? Well, my direction of motion is changing as it actually goes around. So if the force towards the center actually just went away, this object would fly off in the tangent direction. Now, the last part we have to ask about, is it changing, is our acceleration. Well, acceleration is also a vector, so it also has to be changing. Now, which way does it change? Well, let me erase a little bit of this first. Since my velocity is changing on the tangent, my acceleration is also towards the center, and this is also changing as we go. So in this unit, after we look at our pendulum, we're going to look a little bit more in depth in circular motion and how different factors affect it.